finish up this idea on polynomials and their end behavior. I think with where we left off is we were talking about how to figure out the two ends of a polynomial. And we said that, well, the most famous of the polynomial functions are the linears and the quadratics. Okay? Linears will do all of it. You'll follow the slope of a linear for all odd-degree polynomials, and you'll follow the leading coefficient of the quadratic for all even-degree polynomials. Okay. Okay, so, folks, take a look at this. Okay, and so we want to look at this example, y equals negative 7x cubed plus 8x squared plus x. All right, the first thing I'm going to examine is the degree. If you look at this, the degree is an odd degree polynomial. So he's going to follow the same, and his ends are going to follow the same thing as a line. Well, you figure if a line is rising or falling from left to right, we look at his slope. Now, in this case, the negative 7, it's not the slope of the curve, but it will behave similar to a slope when we determine the ends. Well, we know that a line that has a negative slope goes up on the left and down on the right. So I know that this guy's end behavior should be up on the left, down on the right. Now, how do I write that in math? Well, to say the left end of a graph, I say x approaches negative infinity. To say the right end of a graph, I say x approaches positive infinity. Now, every graph goes to the left, every graph goes to the right. What I care about is it going up or down? Well, let's fill this in. What are the two ends doing? Are they going up or down? Well, let's take a look. Since we said that this is an odd-degree polynomial with a negative leading coefficient, he should be like a line where he goes up on the left. So since this is the left side, the left side should go up to positive infinity. And he should go down on the right. So we say on the right side, he's going to go down to negative infinity. Take a look at number 21. First and foremost, 21 is not in standard form. If I were to rewrite this in standard form, I get 6x squared minus 3x minus 1. Now, to figure out his two ends, the left end and the right end, are they going up or are the ends going down? Again, I look at the coefficient. I look at the degree. In this case, the degree is an even. Because that's an even, he'll follow the rules of a quadratic or a parabola. In fact, he is a parabola. Well, for a parabola, don't we figure out whether the parabola is smiling or frowning by the leading coefficient? Since this 6 is positive, I know both ends will go up. The left end will go up and the right end will go up. Well, how do you say up in math? Well, that means y goes up to positive infinity. Y goes up to positive infinity on the right side as well. And so that's the end behavior for 21. Okay, in the last example, number 22, again, this is not in standard form, so I'm going to put this in standard form from biggest exponent to smallest. Negative 15x to the sixth minus 6x cubed minus 4x plus 1. All right, now, ladies and gentlemen, again, looking at the degree. The degree is even. It's going to be like a parabola. Either both ends up, both ends down. Since the leading coefficient is negative, I know both ends will be down. The left end will be down and the right end will be down. So how do I write that in math? Well, the left end is x goes to negative infinity. The right end is x goes to positive infinity. We say the left end, we determined would go down to negative infinity. And we said the right end will also go down to negative infinity. So we'll fill in negative infinities like that. And that is how you figure out the end behavior, and that's how you write it. The last idea is pretty simple. It's the idea of turning points. Ladies and gentlemen, a turning point is just what we call a local maximum or a local minimum, and that's where your graph goes from going up to down or from down to up. In other words, it should look like the top of a mountain or the bottom of a valley. Okay? These both are turning points. Okay? Well, there's a rule for polynomial functions. To find the number of turning points, the maximum number of turning points that a polynomial can have, it's always the degree minus 1. So, if I have a line, for example, going back up to my chart, if I have a line, well, the degree of a line is 1. How many turning points could it have then? 0 turning points. So, in fact, if you think about it, doesn't the line have no tops of mountains or bottoms of valleys? Good. All right, now let's take a look at the next one. And we're back. Ladies and gentlemen, so, yeah, we were talking about turning points. So we know that a line, since its degree is 1, it can have at most 0 turning points. In other words, you better not turn around. Quadratics, because they have an exponent of 2, they would have at most 1 turning point. And we know that a parabola either has a minimum or a maximum. With a cubic, you can have at most 3. I mean, since the exponent of 3, you can have at most 2 turning points. So a cubic might go up, then turn around, and then go down, and turn around, and go back up again. So that could be like a cubic right there, and so on. And that's the turning points. Well, I could talk a little slower, I guess, and make you listen for